All right. So we're going to find non-permissible values, figure out if they're wholes or if they're asymptotes, look for oblique and horizontal asymptotes, find out our intercepts, and then find out what's happening as our graph gets close to those asymptotes. So for our first question, one of the things you're going to do to set this up so that you can find your non-permissible values is you have to factor. Factoring is going to help you with your x-intercepts. It's also going to help you with your non-permissible values. So in this case, when we factor the top x and x, 4 and 1, they both would have to be negative to get negative 5x. And on the bottom we have 1 minus x. And notice that 1 minus x is very similar to x minus 1. So if you factor out a negative on the bottom, you will get the same thing. This is going to be important because what does that mean? We have a non-permissible value. X can't equal 1. Is that going to be an asymptote or a whole? It's going to be a whole because that factor is going to cancel out. What that means when that factor cancels out means that our equation is actually just x minus 4, and on the bottom we're left with a minus 1. Are you okay that y equals x minus 4 divided by negative 1? That's the same as negative x plus 4. Both of those things are going to get divided by that negative 1. So you're going to get negative x plus 4. So when the whole happens at x equals 1, we can actually tell the exact coordinates of that whole. Because when I plug into 1 into my equation now, negative 1 plus 4 gives me 1 comma 3. Now we have to decide, does our graph have any horizontal or oblique asymptotes? Well, now that it's simplified, in this case, this is what it's simplified to. What kind of graph is that? Do you recognize it? It's a line. Do lines have oblique asymptotes or horizontal asymptotes? No. So because we recognize what kind of graph it is, we don't have to worry about those extra asymptotes. So now we can actually sketch this graph. We know that we're going to have a whole at 1 comma 3. How do you graph the line negative x plus 4? You would know that you have a y-intercept at 4. In fact, we can find all of these things. Can you see that you're going to have a y-intercept at 4? And where is our x-intercept going to be? Our x-intercept is going to be at 4 as well. In other words, we're looking at our fraction. What would make this fraction equal to 0? Well, you have an x minus 4 on top. 4 would make it equal to 0. And that can help you draw the rest of your line. So you have a whole at 1 comma 3. It goes through your y-intercept at 4, your x-intercept at 4. This line has a slope of negative 1. You can do that as well. Go down 1, over 1, down 1, over 1, down 1, over 1, and so on and so forth. Now the question also asked us to say the domain and the range. The easiest way to say the domain is that the domain is everything except x can't equal 1. So it's everything but x can't equal 1. And the range is everything but y can't equal 3. That's our interval notation. If you want, that's our set notation. If you wanted to do the interval notation, well, you would start at negative infinity and you would go all the way up until you got to x equals 1, but you wouldn't include it. And then you would start again on the other side of 1 and go all the way to positive infinity. And the u in between means the union means it's either in this side or the other side. Same thing with this one. We could go from negative infinity to 3 but not include it. Start on the other side of 3 and go all the way up to infinity. So in this case, what I've written in the blue, the set notation, I think is nicer. It's everything, and then you just say it doesn't equal 1, doesn't equal 3. Okay, question number 3 is one for practice.